just doing sound check. Stream to Twitter as well. See if that's working. Just doing sound check. Oh, there we go. Just checking everything's up. Kiduki. Well, one thing I've not been able to do this week because just ran out of time was to get Twitch ready. But I'll aim to do Twitch streaming as well for next week for people who like being on Twitch. So I think without further ado, let's crack on. So yep. We were in the middle of the Linux course. Whoops, refresh. I'm a level 32 Acolyte. So yeah, we're only into the second course, but it's early in the year. We're going to smash this one out today. Hopefully we get through all this. And then next week we'll be moving on to the third course and Git. So let's get back to where we were. So we're on programs. Compiled versus interpreted. Yeah, okay, so we're back now. Oh, I do need my headphones though, so put these out. Compiled versus interpreted. So a program is just a set of instructions that just a set of instructions that a computer can execute, and an executable is just a file that contains a program. That the words program and executable are often used interchangeably. Broadly speaking, there are two types of programs: compiled programs, interpreted programs.
A program is just a bunch of instructions written in a way that a computer can carry out. And in a nutshell, there are two kinds of programs. A program is just a bunch of instructions written in a way that a computer can carry out. And in a nutshell, there are two kinds of programs: compiled programs and interpreted programs. For our purposes, the real difference between the two is just that compiled programs do not rely on any other programs to be able to run. They're usually written in a language like C, Rust, or Go, but are then compiled down to binary, the raw language of your computer's hardware. Interpreted programs, on the other hand, do require other software in order to be executed. Python, Ruby, JavaScript, or shell scripts rely on an interpreter to read the code as they run. When you run a program on your machine that has no other dependencies, it can simply be ran by typing the name of the program into your shell. However, when you run an interpreted program, you need to tell your machine which interpreter it should use. For example, to run a compiled program called text editor, you might just type /text editor. To run an interpreted Python program, you might have to type python texteditor.py. And that's because the first one is a compiled binary. It's just ones and zeros that your machine knows how to execute. In the second example, texteditor.py is just a file of Python source code, so it needs access to the Python interpreter.
Nice simple explanation on that one. So a compiled program is a program that's been converted from human readable source code into machine code, binary. Machine code is a set of instructions that a computer can execute directly. Your computer's CPU's hardware that's been designed to execute machine code. Programming languages like Go, C, and Rust produce compiled programs. Interpreted programs. An interpreted program is a program that's executed by another program. The program that executes the interpreted program is called an interpreter. The interpreter reads the source code of the interpreted program and executes it. Programming languages like Python, Ruby, and JavaScript are typically interpreted as they run, which means your computer needs to have the interpreter installed to run the program. Another example is .sh. Shell script files we talked about, those are interpreted by the shell program. Assignment: in your shell, run the following command. Oh wait, let me get my thing out again. Terminal. Just thinking for me for a second. Okay, let's get back to this. So we say which sh. So the which command tells you the location of the installed command line program. In this case, we're asking for the location of sh shell program. Mine is located at bin/sh. Take a look at the contents of that file. So cat. Woo! Keep in mind your sh program is a compiled executable, probably written in C. That's why when you try to view its contents with cat, you see what you see. A file with the .sh extension, on the other hand, is a shell script. It's a text file that contains commands that will be interpreted and run by the sh program. They're both executable programs, but only one can be run without the help of another program. Answer the associated questions. So, what is the output of catting the sh executable? Raw binary encoded is text in hexadecimal. Raw binary encoding text in ones and zeros. Nothing. Which gibberish raw bytes tend to be interpreted as text. That one. No, it's a bunch of gibberish raw bytes attempting to be interpreted as text. Okay, explain that a little bit actually. So Boots, explain it for us. Let me help you understand what happens when you try to view a compiled program. When you use the cat command under sh on the sh executable, you're trying to display a combined binary file as if it were text. Think of it like trying to read a foreign language. It uses completely different symbols. It comes out looking like nonsense. Let's break it down why. sh program is compiled, meaning it's machine code binary. The cat command tries to interpret those binary bytes as text characters. Most of those bytes don't correspond to readable text characters. The result is gibberish on your screen. Yep, so we did that. Cool. On that one. Okay, here's another question again. Which can be executed without the help of interpreter? Compiled executable like the sh program. That. A compiled executable like the sh program. Oh, it's that whole joke of like she bangs, she moves. She bang. As we talked about before, you can run any executable file by typing its file path into your shell. For example, bin/genids.sh. That works out of the box for files that are compiled executables. But what about scripts that need to be interpreted by another program? The computer needs to be told what program to use to interpret the file. The shebang is a special line at the top of a script that tells your shell which program to use to execute the file. The format of a shebang is this. So interpreter, an optional argument. So for example, if your script is a Python script, you want to use Python 3, your shebang might look like this. This tells the system to use Python 3 interpreter located at this address. Assignment: run cat command to view the contents of private bin genids sh file. Paste the shebang. Input the field. Submit your answer. I hope this works for me. Oh wait, hold on. Okay, there's no such thing. So like cat. Oops. Private. No, hold on. What's it saying? Cat come into contents of the private. Oh right, hold on. In this thing, cat private. Oh, cd blank. So cat private. That. Use the cat command. Paste the shebang. Oh wait, right, just the shebang. Whoops, never mind. This. Hey, always read the question. Always read the question fully. Thanks, Bubblegum. And hopefully you will never get the pleasure. Anyway, Bourne shell. So as we talked about before, if you're using Ubuntu on WSL, you're probably running a bash shell. If you're using Mac OS, you're probably running a ZSH shell. If you're running a raw Linux installation, I pray you already know what you're doing. To get handy wavy about it, I want to explain the difference between the three shells you're likely to encounter. SH, the Bourne shell. This is the original Unix shell and is POSIX compliant. It's very basic and doesn't have many quality of life features. Bash, the Born Again shell. This is the most popular shell in Linux. It builds on SH but also has a lot of extra features. ZSH, the Z shell. This is the most popular shell on Mac OS. Like Bash, it does what SH can do, but also has a lot of extra features. Both ZSH and Bash are SH compatible shells, meaning they can run SH scripts, but they also have extra features that generally make them more pleasant to use. For your purposes, the difference between ZSH and Bash are not super significant. Everything we do in this course will work in both shells. just soaking that in. So it's very basic and doesn't have many quality of life features. The born again shell doesn't sh but has a lot of extra features. Bash also has a lot of extra features. So it's going to be ZSH and Bash are a superset of. It's going to be that one. So Bash and ZSH they can do anything as SH can do. Bash and ZSH both have configuration files that run automatically each time you start a new shell session. These files these files are used to set up your shell environment. They can be used to set up aliases, functions, and environment variables. These files are located in your home directory and are hidden by default. The ls command has a -a flag that will show hidden files. If you're using bash rc is probably the file you want to edit. If you're using ZSH rc is probably the file you want to edit or create if it doesn't exist. Assignment: as part of your audit, you're trying to figure out what shell commands run automatically when a user logs onto the machine. You need to confirm which shell configuration file is being used. Edit the file you believe to be in your shell configuration using the nano command to edit files in your terminal. So that, I think, for me, it's going to be bash, isn't it? Oh, 1 minute. Right, we back. Okay, so where was I? Okay. So doing that, add the following line to the bottom. And then I'm not used to thing. Okay, did that. You can use Control O to save the file, confirm any prompts with enter, then Control X to exit the editor. There should be a list of commands at the bottom of the screen. Close your terminal and open a new one. If you see message hello from shell, you found the right file. Edit best games to remove the light. So if I open a new tab, not like that. Hello from shell. Woo! So open it again, and then page all the way down to the bottom, and then we'll just get rid of this. You might restart your shell after changing a shell configuration because you might want to. Why might you restart your shell after changing a shell configuration? Because config file, when you type, I'm not going to say that. Because the config file runs automatically when you start a new shell session. Because the config file runs automatically when you have the shell configuration file. Because the config file runs automatically when you close a shell. How many chapters in this one? Yeah, we'll get through this. Environment variables. We talked about how you can create and use local variables in your shell. There's another type of variable called environment variable. They are variables all programs have that you run in your shell. You can view all the environment variables that are currently set in your shell with the env command. To set a variable in your shell, use the export command. You can then use the variable in your shell as before echo name. The interesting part is that the program and scripts you run in your shell can also use that variable. For example, you can create a file called introduce.sh with the following contents. When we run command executable and then run that, hi, I'm Lane, prints out. Take a look at the contents of one.sh script in the World Bank private bin directory. It looks like it's supposed to print nicely formatted warning messages with World Bank branding. Export the required environment variables. Warning message, the auditor is here, and warning message, your worst nightmare. So I'm going to do that. And then that one. And then we're going to run the so private bin, what was it called, one sh. Oh whoops, I forgot to do the export. And paste in the input field. Ta-da! Path. This is one of the most important lessons in this entire course. Listen up. There are environment variables that are sort of built into your shell. By built in, I mean that different programs and parts of your system know about them and use them. The path variable is one of those. Why do we care about path? If it weren't for the path, you'd have to remember the file system path of every executable you wanted to run in your shell. Instead of just running ls, you'd have to run /bin/ls or whatever the location of ls executable is in your system. That's not very convenient. The path variable is a list of directories that your shell will look into when you try to run a command. If you type ls in your shell will look in each directory listed in your path variable for an executable called ls. If it finds one, it will just run it. If it doesn't, it will give you an error like command not found. What's in the path variable? Take a look at your current path variable. Ooh. Lots of stuff. You should see a giant list of directories separated by colons. Each of those directories is a place where your shell will look for executables. For example, with a path like this, user local bin, user bin, user sbin, and sbin. Your shell will look for executables in the following directories. Assignment: as something of a security engineer yourself, you want to temporarily disable the path variable so that you can only run executables by using their full path. Just so you don't accidentally run something you don't mean to. Reset your path variable to an empty string. This will only affect your current shell session. If you open a new shell, it will have the default path variable again. Try running something simple like ls echo. Something along the way though as a path answer the question. So ls after deleting your path, what happens when you try to run ls? Command isn't found. It lists the contents of the root directory. It gives a security warning. No such file directory. It lists. Change your path. A common problem you'll run into in the future. Smash. Awesome. let's get back to this. Okay, so here we are. So change your path. A common problem you'll run into the future is that you install a new program on your machine, but when you try to run it from your terminal, you get an error like my new program bash, my new program command not found. 9 times out of 10 it's because the program is installed in a directory that's not in your path variable. Oftentimes when you install a program using CLI, it will print a message during the installation process that tells you where the command was installed. Don't let your eyes glaze over when your terminal prints important messages. Sometimes you just gotta what's this one? Okay, fair enough. Read the flipping manual. Assignment: restart your shell to reset your path variable to its default. You can do this by closing your terminal window and opening a new one. The Willbank directory that you downloaded has some executables that would be useful to have in your path so you can run them from anywhere. Add the the World Bank private bin directory to your path variable. You'll need to add the absolute path, not the relative path. You can get the absolute path by running prod in there directory, or by using real path command. To add the directory to your path without overwriting all the existing current directory, you use export command and reference the existing path variable. Okay, the path part is the reference to the existing path variable. The colon separates the existing directories from the new directories, and what you're adding. CD to the World Bank directory, CD outside the World directory, and try run sh. Okay. Real path command. So a real path was private bin. Okay, and then it's going to be okay, and then we're going to cd to user, and then we're going to run world bank.sh. Follow the prompts, then copy and paste the entire interaction with the tool into the field and submit your answer. Start with welcome and ending with goodbye. Nope. Gotyou.com. Hooray! Path config. In the last lesson, you changed your path variable for your current shell session. Trouble is, the next time you restart your shell, it will be reset to its default value. You won't be able to use Willbank.sh CLI tool from anywhere unless you change your path variable permanently. The most common way to do this is to add the same export command they used in the last session to your shell's configuration file. Assignment: edit your message and add the export command to the end. Yep, that's fine. Restart your shells, run it, make sure it works again. Yeah, we're not going to go through that, it was just we know it'll work. So you add it to the bash file, and you basically just add that same command that we ran there a minute ago. So where is it? This one. We don't need to do it again like that. What changed when we added the path change to the config file? We need to use the full path to run the rest available from anywhere, even after session restart. That one. Man. The man command is short for manual. It's a program that displays the manual for other programs. Read the flipping manual. I know that manuals and documentation can feel intimidating. Heck, that's why there are even courses like this one to give you a general introduction. That said, manuals and documentation will become more useful as you become a more experienced developer. They're not as scary as they seem, and we actually take time to read them. Using man, the man command can only work for programs that it has a manual for, but most built-in commands in Unix programs are supported. You just pass the name of the command as an argument. The most intuitive place to start, of course, is reading the manual. Give that a try. Oops. Circle man. Hey. Searching. Most people don't just read man pages for fun. More often the manual is used as a reference to quickly look up usage or special flags. You can search for text in the manual by pressing / key and typing your search, then pressing enter. Let's try look up the R flag does in the ls command. So man ls, so man ls, and then name list directory contents. So / so then enter. As a systems person, the grep command will be your best friend. It has a lot of power. As a systems person, the grep command will be your best friend. It has a lot of power, but can be a little confusing to use. Open the grep manual. So just quit out of that. Man grep. You'll notice that the manual is an interactive session. Page through the manual with the spacebar and quit using Q. Read the first couple of paragraphs of the grep manual and answer the question. Okay. So grep searches for patterns in each file. Patterns is one or more patterns separated by new line characters, and grep prints each line that matches a pattern. Typically, patterns should be quoted when grep is used in a shell command. A file of dash stands for a standard input. If no file is given, recursive searches examine the working directory, and non-recursive searches read standard input. In addition, the variant programs egrep, fgrep, and rgrep are the same as grep-e, grep-f, -f, and grep-r respectively. These variants are deprecated but are provided backward compatibility. Okay. What did it say? What does the lowercase v flag do? Selects non-matching lines, prints the version, matches the lines that start with v. That one. Whoops. Hey. Selects non-matching lines. Which option is correct? Dash test, dash recursive, ignore case count, that one. Oh no. The grep. I've not read that at all. Version. What was it? Test, ignore case count. Is correct count. What? Oh, is incorrect. Whoops. Test. Always read the question. Keep saying it. I'm doing a bad job on that one. Flags. Have you already seen in this course some commands accept flags? Flags are options you can pass to a command to change its behavior. Change its behavior. For example, the ls command can take a -l flag that shows a long listing of files, or the -a flag will show all files including hidden files. You can also combine flags -al conventions. Whether or not a command takes flags and what those flags are is up to the developer of the command. That said, there are some common conventions. Single character flags are prefixed with a single dash. A multi-character flag are prefetched with 2 dashes. Sometimes the same flag can be used with a single dash or 2 dashes. you found that some of the files have been tampered with. To figure out which one it is, you need to know the number of bytes contained in each file. Use the word count command to count the number of bytes in World PR ideas file. Use the man command to figure out which flag you need to use. So, okay, so WC this. It's going to be okay, so man WC count the number of bytes, so dash bytes, print the byte counts. Okay. Paste the number of bytes and say input field and submit. Yay! Positional arguments. Programming languages have functions and functions take arguments. For example, this Python function takes 2 arguments, x, b, and level. It can then be called with 2 arguments. In a shell, commands programs can also take arguments. For example, the cd command takes a single argument, the directory to change to. Other commands might take multiple arguments. For example, the mv command takes 2 arguments, the file to move and the destination to move it to. Assignments. Take a look at inside the world public directory. Count the contents of the suspicious looking key.txt file. This looks like some kind of private key. Why is it in the public directory? Okay, so cd public cat was it keys, move it from World Bank public key to private. List the contents of the World Bank. So okay, mv key to private there. List the contents of World Bank private. So ls private. Hooray! Help. By convention, most production-ready CLI tools have a help option that prints information about how to use the tool. It's usually accessed with one of the following: help flag, help or help first positional argument. The help output is often easier to pass than a full man page. It's usually more of a quick start guide than a full manual. Assignment: you need to make some network requests as part of this audit. You want to make sure that this machine you're auditing only has access to authorized systems. To make those requests, you'll need to know how to use curl. It's a CLI tool that lets you make network requests from the command line. Print out the help command for curl. Paste the command you print using the menu, not the menu itself. So curl dash help. Exit codes, sometimes called return codes or status codes, are how programs communicate back whether they ran successfully or not. 0 is the exit code for success. Any other exit code is an error. 9 times out of 10, if a non-zero exit code is returned, meaning an error, it'll be a 1, which is the catch-all error code. Programs that call other programs use error codes to figure out if execution was successful. For example, if the Boot.dev server program exits with a non-zero code, we have another program that will automatically restart it and log the error. In a shell, you can access the exit code of the last program you ran with the question mark variable. For example, if you run a program that exits with a non-zero exit code, you can see what it was with the echo command. Unless it does not exist. Echo that. 0 does not exist. Assignment commands are usually we usually exit with error codes if they've been run without proper arguments or configuration. For example, the private/bin/1.sh script will exit with a non-zero code if you don't have the required environment variables set. Run the 1.sh script without setting the 2 command variables. Run the echo command to see the exit code. So it was in private, private, what was it called? Bin 1. So echo dollar question mark 69. Yay! Standard output. You might not even know it yet, but you're already a pro at using standard output. You've been using it since you started the first exercise in this course. Standard output, usually called standard out or std out, is the default place where programs print their output. It's just a stream of data that prints to your terminal. But we'll talk later about how it can be redirected to other places. All programming languages have a simple way to print to standard out. In Python, it's the print function. In a shell command, it's the echo command. Assignment: use grep command to print all the lines from the World Bank file that contain the word Marshall to standard out. Copy the output of the text field and submit your answer. So, forgot grep. Help. Need to get better with grep. So, use file. -I, ignore case. Okay, so grep, and what is it? Marshall. Marshall. Single quotes ma. Yeah. Copy the output into the text field, submit your answer. Marshall. Oh, with 1 L. 3. Silly me. Yay! Standard error, usually called std error, is a data stream just like standard output, but is intended to be used for error messages. It's a separate stream so that you can redirect it to a different place if need be, but by default it prints to your terminal just like standard out. Redirecting streams. You can redirect standing out an STD directory to different places like less greater than, two greater than operators, greater than redirects, standard output, and two greater than redirects standard error. Redirect to a STD out file, so echo that and that. So you can just echo that to the txt file and cat, and there it is. Redirect STD error into a file. Just like this and like that. Assignment. There is a process transactions sh script in the World Bank private bin directory. It accepts a path to a transactions CSV file as a potential argument of CLI commands. It prints minor transactions after the year 2000 to standard out, and all transactions before the year 2000 to standard error. Run the script and pass it the path to 2020 CSV file in the World Bank private blah 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 directory. Be sure to redirect standard out error to a temporary file called /temp World Bank log. Okay. So we're going to do private bin, what was it called, process, and then we're going to give it so private path, private transactions /2020 CSV, and then redirect so to /temp worldbank.log worldbank.log. So cat temp worldbank.log. If you're missing the 2020, you made a mistake in the previous step, make sure it's blah 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 blah. Cat that and temporary directory does exist. Okay, I did that, so let's copy it. In it goes. Yippity squippity. Standard in, there's a standard output, but there must be a standard input, right? Standard input, usually called standard in or STD in, is the default place where programs read their input. It's just a stream of data that programs can read from as they run. All major programming languages provide a simple way to read from STD in. In Python, it's the input function. Execution stops until the user types something like, in this case, lane, and presses enter like that. So input, what is your name? Name. So run the World Bank sh program again. Notice that it makes use of the std in to read your name and email. Take a closer look at the code in World Bank sh file. What command does it use to read from a standard in? Copy the command's name into the input field. Submit your answer. So cat private bin, what's it called? World Bank. Read. Oh, yay. One of the most beautiful things about the shell is that you can pipe the output of one program into the input of another program. With this one simple concept, you can run incredibly powerful automation tasks. The pipe operator is pipe. It's the character that looks like a vertical line. It's usually on the same key as backslash above the enter key. The pipe operator takes the standard out of the program on the left and pipes it into the std in of the program on the right. Let's see. Have you heard the tragedy of Darth Plagueis the Wise? Yes, indeed, I've heard the tragedy of Darth Plagueis. Plagueis? In the example above, the echo command sends, "Have you heard the tragedy of Darth Plagueis the Wise?" to standard out. However, instead of that being sent to your terminal, the pipe operator pipes into the WC word count command. The WC command counts the number of words in the input it receives. The W flag tells word count to only count words. This only works because WC command, like most shell commands, can optionally read from standard in instead of a file path. Assignment. We need to figure out just how many transactions Bob has been involved in. Bob's looking sus for real. Use the grep command to find all the lines in all the transactions that include the word Bob. You'll want to include all the files in the transactions directory, but not the files in the backups directory. Use exclude directory like that. So like that. And then we're going to get rid of that. It's going to be, what was it, in private transactions. Private transactions. Yikes! Pipe the output of the command into the WC-L command to count the number of lines. So that. And then WC dash count. Dash L. Pipe out the paste the number transactions, just the number. Yay! Interrupt. Sometimes a program will get stuck and you'll want to stop it. Common reasons for this are you made a typo in the command and it's not doing what you want. It's trying to access the internet but you're not connected. It's processing too much data and you don't want to wait for it to finish. There's a bug in the program causing it to hang. In these cases you can stop the program by pressing Control-C. This sends a SIGINT signal to the program which tells it to stop. Inside the Willbank private bin directory, there's a program called malicious.sh. Sounds scary. As a good security auditor and knowing what you're that you are on a secure system with no internet access, you want to see what the program does, go ahead and run it. It will run forever if you let it. Use Control-C to send a SIGINT to program to stop it. Paste the line of its output into the text box and submit your answer. So private bin. What was it called again? Malicious. Doing scary stuff. It will run for a few legs. Paste the last line of the output. Alright, okay, so. Ooh, malicious skullduggery complete. Yay! Kill. Sometimes a program is in such a bad state or is so malicious that it doesn't respond to the SIGINT, in which case the best option is to use another shell session or terminal window to manually kill the program. So kill PID. PID stands for process ID. Every process that's running your machine has a unique ID. The PS process status command can be used to list the processes running your machine and their IDs. So hope I don't want to regret this. Try this one. No, it's pretty simple, that one. Okay, that's cool. The AUX options just mean show all processes, including those owned by other users, and show extra information about each process. Assignment. You did something digging around and found that the malicious program actually has another mode, force. Run the program in force mode. So, private bin malicious force. Open a second terminal window and pipe this thing, the output of PSX. Okay. Okay. So this won't respond to. Haha, you can't stab me. So cd mount the users me documents GitHub is it tech Boot.dev. And there. Try to kill the growing increasing cursor. You won't be able to kill it. Copy the line that was printed to your terminal when trying to kill the malicious program. Control C. Paste into the input field, but do not submit it yet. So, what's he saying? Haha, you can't stop me. Open second terminal window and pipe this thing, the output of PSAUX into grep malicious to identify the processor of the malicious thing. So grep is it World Bank private bin malicious, and then pipe it into PAUX. In fact, it's the wrong way around, isn't it? Hold on. PAUX pipe. Where's pipe? Oh, pipe. You will probably get two results, one for the malicious program, one for the grep command itself. Make sure you use the correct PID and that you don't miss any characters. You don't want to accidentally kill a system critical process. Once you have the PID, it should just be the number of the line. I can kill it. So once you kill the program, you should see the original terminal window. So it's going to be that one. So kill that. No such process. Whoops. Kill that. No such process. You'll probably get two results, one for the malicious program, blah, blah, blah. Once you don't kill it, once you kill the program, you'll see your original terminal when you return to a new prompt because it stopped the malicious program. With control of your terminal stored, submit the message in this program before you killed it, which should have copied already in step 2. Oh, come on. Come on, Boot.dev, you can do it. Oh, it's having to really think about this one. Just reload the page, see what's going on. Correct. Hey. Unix philosophy. The Unix philosophy is a simple set of principles that have guided the development of Unix-like operating systems for decades. It can be summarized as write programs that do one thing and do it well, write programs to work together, Write programs to handle text streams because that is a universal interface. Write programs that do one thing and do it well. This is why programs like ls, grep, and less exist. They do one thing and they do it well. They don't try to do too much. ls lists files and directories. Grep searches for text. Less displays text. Write programs to work together because, at least according to the Unix philosophy, programs should do one thing and do it well. It's easy to write programs that work together. For example, if you use grep to search for a text in a file and then pipe the output of grep into less, display the results interactively. Write programs to handle text streams because that is a universal interface. This point is more of the how than the previous point. Programs work together easily when they all use the same interface, text streams. A text stream is a sequence of characters that can be read or written sequentially. In other words, a text stream is just text. This harkens back to the point we were talking about at the beginning of this course. The shell is a command line. Text-based interfaces are much more powerful and extensible than graphical interfaces. That's why developers have been using them for decades, and why what we can do with them looks like magic to the uninitiated. Which of the following does not follow the Unix philosophy? Boom. That was a little bit of an easy one. The Unix philosophy is a simple set of principles that have guided the development of Unix-like operating systems for decades. It can be summarized as write programs that do one thing and do it well. Write programs to work together. Write programs to handle... Alright, we already read this. Which is the more powerful interface, at least from extensibility and interoperability perspective, so text. The top command is a powerful tool that allows you to see which programs use the most resources on your computer. I use top command all the time, both my local machine and remote service, to diagnose performance issues. If you've ever opened your task manager on Windows or activity monitor Mac OS, top is similar but for the command line. Open your terminal and run top command. Oops. Notice that the top command runs in a loop, updating the information every few seconds. Yeah, it is. By default, top sorts the processes by CPU usage, with the most CPU intensive processes at the top. Another useful resource to sort by is memory, RAM usage. To sort the memory usage, press M uppercase while top is running, so M. What programs on your computer are using the most CPU and memory? Poke around a bit to see what you can find. Copy the column names from your terminal entire top row of top commands output and paste them into the text on the right. Don't submit yet. Exit top by pressing the Q command. Top might not print some columns in your terminal window isn't wide enough to fit them, so try resize your window or zoom out, reduce font size to ensure you print all the columns, otherwise submission might fail. If your system is set up with a non-English locale, make sure that your printed output matches the expected running this instead. Well, I think it's in English, so it should all be fine. Right, we're on to the last one for this, package managers, and there's only 6 things in here. VS Code. Woo! Who's in your bit? NeoVim? Using NeoVim. Hey! And then we'll be getting on to the next course. Woo! Tonight. Getting on to the next course. Package Manager is a software tool that helps you install other software. Its primary functions include downloading software from official sources, installing software, updating software, removing software, managing dependencies. As a developer, you'll frequently use package managers to get access to the software you need to get your work done. App Ubuntu. APT or Advanced Package Tool is the primary package manager for Ubuntu. To be fair, you can use other package managers on Ubuntu, but apt is the default most common. If you're using WSL on Ubuntu, you'll be using apt. If you're using another Linux setup, I pray you already know what package manager you're using. If you're using WSL or Ubuntu, check to make sure you have apt installed by running the following command: apt-version. Brew macOS. There isn't a default package manager for macOS. The most popular but unofficial package manager is Homebrew. If you're on macOS and you don't have Homebrew installed, you can install it by running the following command. See the Homebrew site for more details. Assignment. Let's install something. NeoVim is a hyper-extensible and newer version of Vim, which is a new version of Vi, which is a popular command line text editor. WS Ubuntu instructions. So make sure apt itself is up to date, and we'll install the latest version of NeoVim by running the following commands: sudo apt update. This command only updates apt, it doesn't upgrade anything else. Next install NeoVim. So okay, to apt update. So yep. Whoops. Okay. Then we'll run sudo apt install NeoVim. And then we'll check the install nvim version. Okay. Nvim dash version. Yay. I mean, NeoVim's never been a V1 release. That's interesting. Paste the output into the input field and submit. Whoops. Yay! This isn't a course on NeoVim. We need at least 420 more lessons for that, but let's at least figure out how to edit a file and exit the program. How to exit Vim? No, it cannot be done. Don't be fooled. Exiting Vim or NeoVim is one of the greatest hurdles you must overcome as a developer. It's a rite of passage. It's a badge of honor. I've been using Vim for about 2 years now, mostly because I can't figure out how to exit it. Simon, there is a public file. File containing a company password. Use NeoVim to open World Bank public company info.md file. It's a text file that's using Markdown syntax. You can open a file using NeoVim by passing the file path like this. So nvim like that. Oh no, I'm stuck. I'm stuck forever. Use the arrow keys. I know, Vim sacrilege. To move your cursor down to the last line. And to insert more by pressing I on the keyboard if you see insert appear at the bottom of the screen. So I. You should now be able to delete the password. Replace just password with redacting all caps, no quotes. Redacted. When you're done, press the escape key to enter normal mode. When you type W, press enter to save changes. W, and then W Q. Press enter to quit NeoVim. You successfully edit the file and escape NeoVim. You can use cat to view contents on it. Q. Oh my goodness. Use cat to view the contents of the edited file and paste the contents in there. So public company info. Like that. Submit. Package manager review. Apt and Brew aren't the only package managers out there. There are many, many more, though they do happen to be the two most popular, especially on Linux and macOS. How does a package manager work? When you type a command like apt install NeoVim, the package manager will check to see if the package already installed. If it's not installed, it will download the package from a repository. It will install the package on your computer. It will install any dependencies that the package needs to run. It will hopefully add the package to your path if it should be there. Good package managers keep track of what packages you installed and what versions of those packages you installed. They keep your file system nice and tidy, making sure you haven't installed 10 different instances of the same package or application. For your edification, take a look where your package manager installed NeoVim in your file system. Use the which command. So which nvim. Yeah. What do package managers like apt and brew not do? Manage installation of pathways. Do anything to download software on the internet. Debug code and fix bugs. That one. Webby. There is more. There is one more package manager. Actually, more of an anti-package manager I want to introduce you to. Webby. What is Webby? Webby's on the FS installed developer tools easy. Install. Okay. Webby lets you install command line tools directly from the web with no need for local command line tool like apt or brew. You don't need to install Webby itself at all. Instead, you just run a shell command that downloads and runs the tool's official installer script. Let's install LSD. Modern version of ls command. It's essentially ls with a bunch of extra features. Go to Webby and look for LSD. LS Deluxe. Whoops. Oh, hold on. Navigate to its page and select the correct instructions to install into your system. You should simply need to copy and paste from a single command in your terminal. So that one. That. Make sure LSD works by listing all the directories in this thing here. So LSD like that, LSD like that. Try running LSD with the tree flag on the private one. One of the coolest features of LSD is that you can view your files in a tree-like structure. So tree. Ooh, that's nice. Run it again with both tree and classic flags on the World Bank Transactions private directory. Paste the output into the field. As a general rule, it's not smart to pipe a shell script from the internet directly into a terminal because that script could do malicious things. That said, as long as you're doing it via HTTPS, which you are, you trust the source. In this case, web install.dev. It's not a big concern. If you want to hear more about it, here's the section of backend banter podcast episode. Blah 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 blah. And classic. Yay! Gosh, we are almost done. Up to this point, in Boot.dev, you've written code in Boot.dev's in-browser editor and you've used a standalone terminal. Now, some developers do their work inside a terminal and use a terminal editor like NeoVim, but a lot of developers, myself included, prefer to use a hybrid GUI terminal experience. Enter VS Code. It's a fairly lightweight editor. It's easy to use for beginners, but powerful enough for professionals. VS Code, not to be confused with Visual Studio, is the most popular code editor among developers today. Some other cool GUI editors include Zed. I actually switched to Zed from VS Code recently, but it doesn't work on Windows/WSL. Cursor, IntelliJ IDEA, and some of the most popular terminal editors are NeoVim, Vim, and Emacs. Assignment: if you don't already have a preferred editor, install VS Code on your machine now. I'm done with this step. Yay! WSL in VS Code. If you're on Mac or Linux WSL, you can skip the step. However, if you're on WSL, you need to set up VS Code to work with WSL. This will allow you to use full power of Linux file system within VS Code. Open VS Code, navigate to extensions. Let me close the. I'll keep the terminal there for a second. I'm just going to check. I don't mind you guys seeing my website. WSL. WSL. It's already installed. In the very bottom left corner of VS Code, there should be a green and blue button. Click on that and select Connect WSL using distro and select Ubuntu. You should now have a new WSL ready VS Code editor. You can close the VS Code window for now. I recommend pinning this new window to your taskbar so that you can always open WSL enabled version of VS Code in one click. You don't have to access your Linux file system if you're in the regular VS Code window. So just avoid it completely. Select file, open. So this one, so we say unpin, I want to say pin to taskbar. It's going to stay like that. Okay. I think that'll be that. I've done this with this step. Yay! We completely learned the Linux course. Huzzah! me add that to photos. Add photos, downloads. Hold on. Details. Is it today? What does it say? Notification, like that. That, add photo. That one. I've done that, and then I think I've done that, so boom, I'll come back to those later. Claim 400 XP. Woo! Now is the time for some rewards. Close that. Finishing off site. Great introductory course for beginners. I learned a couple of tricks too. Rates costs. It's 5 out of 5. Nothing to complain about. Did have one like. I'll skip that one for now. Woo! Got some baked salmon and stuff. Nice. Bingo, wingo. That's another one. Bitten the dist. We've got half an hour to start the next one. So as I look at here, yes, it's done. It's done. So the next one we'll be doing is Git. Git, my boy. Yeah, sure. This is gonna be good. Gonna be good. Okay, well, we're entering the Git course. the Git course is authored by none other than the Prim EA Gen, the Prim Egan, the Prim Egan himself. Awesome. Well, we're on to it tonight, so we might as well spend the next half hour wisely. Let's get into this and we get our way through it. Start the course. Here he is, the Prim Egan himself. Git is the distributed version control system nearly every developer in the world uses it to manage their code. It has quite a monopoly on VCS. Developers use Git to keep a history of their code changes, revert mistakes made in their code, collaborate with the developers, make backups of their code, and much more.
In 2005, after license disputes with BitKeeper, Linus Torvalds, creator of Linux, you may have heard of it, sort of runs the web, not a big deal, decides to write his own version control. He wrote Git in 5 days, and within a couple years, it became a widely used version control, and now, today, it is the de facto standard for all developers. To be clear, when I say Git, I don't mean an insult from across the pond, and I don't mean GitHub, GitLab, Stash, or any of the others. All of those companies use Git. They are not Git. Git allows you to track code changes over time by author with a set of commands to search, manipulate, and revert history. In simple terms, Git creates a commit. A commit is just a set of changes tied to an author, time of day, and other information. As many commits as you want can be added to the graph. At any commit, you can branch off and create new commits on the new line. Any of these branches can be merged into any other branch, including the main line. Commits can be squashed into one commit, and commit messages can be edited. Also, Git commits can be reverted, just in case they don't want terrible code. Git is a very complicated piece of software, but the interface and operations are very simple. And in this course, we're going to be going over installing and configuring Git, porcelain and plumbing commands, inspecting Git history, branching, merging, and rebasing, undoing changes, and remote repos and GitHub. I hope you enjoy this course, and in about another month or two, I will be releasing part 2, which will go over all the advanced features, advanced techniques with merges and rebases and conflicts, and of course, just really diving into some of the more complex parts of Git. But in this course, you should be able to get everything you need to become quite proficient in the real world, including understanding how Git works. The name is the Gitagen.
Is the Prim Egan. Throughout this course, you'll be using Boot.dev CLI to run our tests, which are just CLI commands against your local environment. Install it now if you haven't already done it. All the instructions and troubleshooting are on the GitHub page. Install it now. Oh. Ooh, official Boot.dev CLI still go to layout. Okay. Make sure the Boot.dev CLI install works. So install like that. Terminal. cd /note b users me GitHub documents GitHub greenwash tech and then boot // and then throw it across blah 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 blah. You start now. So Boot.dev version, I do not have that. So how do I install that? So installation, install Go 1.2 or later. Boot.dev requires Golang installation, only works on Linux and Mac. If you're using Windows, you'll need to use WSL. Make sure you install Go in your WSL to make your command. Blah, 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 blah. Option 1 will be install. Use the official installation instructions. Run Go version on your command line. Go not found, so let's use the official installation instructions. So Linux, any piece of go installing. Downloading so quickly the following subscribe for other content installing. Might be interested in managing Go installations, installing Go from source. Found a ticket, so select tab for your computer thing. Remove any previous Go installation by deleting local folder that extract the archive just so me to run the command as root or sudo though. Okay. So no such thing exists. So there's this bit. So tar that. I can open such file or directory. ls / user local. Let's do it the webby way. Okay, got Go version working now. Is there anything else? Install boot CLI, so go install this. Go install that. Boot.dev version. Boot version that. So log in to the CLI, run boot.dev login. Boot boot.dev login. Whoops. Paste your login code. Let's open this. Logged in successfully. Huzzah. That was crazy how I did that. And then boot login, reverses a bit. So, boot.dev CLI, that was a bit of an ordeal. Not an ordeal, but it was kind of cool. Run versus submit. Each lesson has a list of commands that runs on your local machine. A series of tests that will track against the results of the command. There are 2 ways to run these commands: run and submit. Boot.dev run ID. This will run the commands and show the results. It's to be used for debugging, but it won't tell you whether or not you've passed the test explicitly. And then Boot.dev run ID-S. This will run the commands and give you pass-fail feedback. It will also mark the lesson as complete on the website. If you get it wrong, however, you'll potentially use your sharpshooter spree, so be sure to use run first. You can copy and run the commands with the ID ready to go from the terminal. Test panel assignment. From right into a terminal execute. If it's printing, rebasing is rebased. Run these commands to test your solution. Hey, that's awesome. This is really cool. This is really awesome how this works. So install Git. Git is a command line 2 version, just like boot.dev CLI. Let's install it. So first check, see if you have Git installed. Open a terminal and type git-version. So git-version 2.4.45.2. If you see a number version, you're good to go. Run and submit the tests. Yeah. Cancel that for a second. Let's run that way. Okay, and then run this one. Happy days, happy days. RTFM. One of the best parts of using Git is that all the documentation is fantastic. But that wasn't always the case. Git was known as being the most obtusely documented tool of all time, but alas, times have changed. What we got? So, yeah. Get through a couple of these tonight. Last times they changed. Let's take a look at the official Git manual. Run the following command in your terminal. Manual Git. So shortcuts for manual. Q cuts the terminal. 1 line down, 1 line up. Half page down, half page up. /term for the search for term. Next, search for the term authors, all caps, and answer the question. So authors. Answer the question. Who created Git? Linus Torvalds. Already knew that one. Command syntax. Throughout this course you'll see commands looking like this. Command required, optional. Arguments in angle brackets are mandatory and must be provided when running the command. Arguments in square brackets are optional and be included if needed. For example, to create a new directory in your terminal, you'd run mkdir and directory name. mkdir's command, directory name is a required argument. Command arguments in angle brackets are required, arguments in square brackets are optional. In Git, commands are divided into high-level porcelain commands and low-level plumbing commands. The porcelain commands are the ones that you'll use most often as developed to interact with your code. Some porcelain commands are git status, git add, git commit, push, pull, log. Don't worry about what they do, we'll cover them in detail soon. Some examples of plumbing commands are git apply, git commit tree, git hash object. Focus on high level commands because that's what you use 9% of the time as a developer. We'll dip down into the low level commands occasionally to really understand how git works. 9% of the time, porcelain commands are used to interact with git. I wonder why they're called porcelain commands anyway. It's a very interesting term. We need to configure Git to contain your information. Whenever code changes, Git tracks who made the change to ensure you get proper credit or more likely blame. For all the code that you write, you need to set up your name and email. Git comes with a configuration both at the global and repo project level. Most of the time, you'll just use the global config. Let's set your identity. Check if your username and email are already set. I'm pretty sure they already are. So quit that. Let me just check what my GitHub username is. Pretty sure it's admin. Hold on, I ain't going to show you any of this. Okay. Surprised those weren't set, but doesn't matter. It's set now. Okay, so they set finally. Let's set a default branch. We'll talk more about configs and branches later, so we can all be on the same page. So that git config global init default branches master. We're using master for now because it is Git's default, but we'll change it to main, which is GitHub's default. Just bear with us for a second. Make sure it worked. So your git config file stores your Git global configuration view with cat git config. Oh yes, forgot about that. Anyway, we'll come back to that. So running these commands. Hey, happy days. All set up. Repositories. Repositories config. Can we get through chapter 2 tonight? I think we can. It's only a short thing. Six things. We're through chapter 2, and then we're through 2 of 11. Next we've got 2 thingy sessions. We could probably smash this one out in one night, and the course after that will be getting into something juicy. We're going to be building a project, so that'll be good stuff. So the very first step of any project is to create a repository. A Git repository or repo represents a single project. You'll typically have one repository for each project you work on. A repo is essentially just a directory that contains a project, other directories, and files. The only difference is that it also contains a hidden .git directory. That hidden directory is where Git stores all of its internal tracking and versioning information for the project. Webflix. In this course, we'll be managing content for Webflix, an imaginary self-hosted video streaming application. Webflix serves content directly from a Git repo. Assignment: navigate to somewhere in your file system where you'd like to store your project. Once you're there, create a new directory called Webflix and cd into it. So we are here, so I will make this here and cd into Webflix. Once inside, create a new Git thing, so Git init, and ls/. You should now have a hidden Git directory in your Webflix directory. This means you've successfully created a new Git repository. ls-a, the contents of the directory to confirm. So we'll just run that straight off the bat. Bingo! Level 2. So, status. A file can be in one of several states in a Git repository. Here are a few important ones. Untracked, not being tracked by Git. Stage, marked for inclusion in the next commit. Committed, saved to the repository's history. The git status command shows you the current state of your repo. It will tell you which files are untracked, staged, and committed. Every good content management system needs a table of contents. Create a file in your Webflix called contents.md and add the following to the file. So we're going to do just mvim, what was it called? Contents.md. Just going to paste contents, is it? So, yep. Right, quit. There we go. Save the file, then run git status. Git status. On Brasher, no commit yet, untracked file. Run and submit the test from the Webflix directory. Troubleshooting, blah blah blah. So run that. Huzzah! This is so cool being able to do this with the CLI tool. Staging: the contents .md file has been created, but as we saw, it's untracked. We need to stage it, add it to the index in the git add command before committing it later. Without staging, every file in the repository would be included in every commit, but that's often not what you want. Here's the command: git add. For example, I use arch, by the way. And assign add contents.md to the staging area. Run git status again. Run and submit CLI test. So just say git add contents, and then git status again. Git status, status, and it's staged but nothing added. So there, fix that in. Yippee! Skippity whippity. How many lessons we got? Only 6. We'll finish this one and then we'll lock up for the night because this is going well. After staging a file, we can commit it. A commit is a snapshot of a repository at a given point in time. It's a way to save the state of the repository, and it's how Git keeps track of changes to the project. A commit comes with a message that describes the changes made in the commit. Here's how to commit all your stage files. So do that. So commit the contents with a message. Add contents.md. You wouldn't normally start a commit with a colon. You just write the message, but we're going to use the letters to help us easily identify commits in this course. Run git status again. So, whoops. Git commit. And then you do that. And then what was it? Write out and quit. And quit. Run git status. Run git status again. You should see the file as long as stage git status. Okay, and then run the CLI commands. Bingo wingo. Half of Git. You learned half of Git. Well, not really, but kind of. Half of your workflow as a developer will just be three simple commands: stay as, add, commit. It's most of what you need to work effectively as a solo developer. Another 40% of Git is about collaborating and storing your work in a remote server. The last 10% is mostly about fixing mistakes, rolling back changes, and other advanced topics. Don't worry, we'll cover those too. Which command adds a file to the staging area? Add. And then a git log, so a git repo, potentially very long, list of commits, where each commit represents a full state of the repository at a given point in time. The git log command shows a history of the commits in a repository. This is what makes Git a version control system. You can see who made a commit, when the commit was made, what has changed. A commit hash. Each commit is a unique identifier called commit hash. This is a long string of characters that uniquely identifies the commit. Here's an example of mine. For convenience, you can refer to any commit or change in Git with using the first 7 characters of its hash. For mine, it's this. Assignment. Run the git log command. You should see your commit. Notice the git log, assuming the log is long enough, starts an interactive pager. You can scroll through the log using the arrow keys and exit by queue. Next, run git log again, but this time, actually git log so you can see git log. It's just one thing, so there's no scrolling. Next, run git log again, but this time use -n and --no pager to limit the maximum number of commits shown, and more importantly, to run it without the interactive pager. So no pager, log, and -n, like that. Same thing anyway. We're going to submit the tests. Boom, and then we're on to internals. So we're going to stop there for tonight because there's a few on this one and I don't want to go over on time. So we do this. So that's locking up for the night. That was fun. Finished the Linux course, and then we've been getting down into the Git course, and it doesn't look like it's going to take too much longer to get through that. I think next week we'll probably get through it through that one in one night and start the project on the next night. I'm also going to start streaming on Twitch next week. I'll try and get my channel set up and everything and stuff, and just kind of get going on there as well, because a lot, you know, why not do it anyway, so might as well. I'm not a big user of Twitch, but just get that out there. Cool. Well, thanks for coming along. If you had fun watching, let me know in the comments. Send us a message, reach out to us on X, Twitter, whatever you want. Hope you learned a little bit of something during this one, and have fun. Thanks very much, and I'll see you next week.